My name's Joris Peels, and this is another edition of 3D Printing News Unpeeled, thanks to 3dprint.com. And today we're going to look at a couple of 3D printing news items for you. And the first one is from MIT. And this one is, well, essentially MIT is working on a 3D printable tricorder. So that's good news for everyone, I think. They want to make kind of robust portable mass spectrometers. Now, one of the problems in making portable mass spectrometers is the fact that the pump element, which is a key part of that, is quite big, quite expensive, quite bulky. And so they're looking a way around it. And what they essentially made is what you can see in front of you, and that is a 3D printed rotary peristaltic pump. Now, a peristaltic pump can be used for other things as well, some medical devices perhaps, and some other maybe mechanical things. Essentially, they made kind of a tube, which is 3D printed, and they put it around what I'm going to call it a fidget spinner, right? And essentially, a fidget spinner, uh, you know, uh, uh, moves and controls a tube, let's say, that is rolled around it. And by 3D printing it, they can make this thing quite inexpensively, quite cheaply, and they can make it remotely. And this means that they could make it in an austere environment, maybe make it in a developing country, maybe make it in just a lab at a high school or a college somewhere else, or maybe use this and print it and use it on the moon. Um, so this is a fantastic area. We keep kind of seeing things like this, um, where people are making either medical devices or experimental devices or science kind of tools such as microscopes and scanners and things like that, using 3D printing. I think this is a very, very overlooked area because it means that you can make a low cost treatment device that you could use in many, many areas. Now, this is a very complicated example, but we've seen other like malaria testing collection kits, for example, things to use your iPhone and a kind of a mount for your iPhone so that you can put it on your skin and then send the right pictures back to the doctor so that a dermatologist in another country can analyze what's wrong with you, that kind of thing. There's a lot of stuff going on. It's not really, it doesn't really have a name. It's like kind of like it's embedded in kind of this whole open source hardware movement. But a part of this is low cost open source medical devices, low cost open source scientific devices, low cost open source educational devices, and low cost open source design devices for development. Think of holders for solar panels or filters for water. And this is a movement that is it's happening, and it doesn't get enough press. It doesn't get enough, I think, because it just doesn't have a name or anything like this. It just doesn't get enough mention. I think this is another fantastic example. This rotary peristaltic pump. Now, one of the researchers said that 3D printing was key to making this item just because they were able to iterate again and again to get this pump exactly right. And it was one of these things where you had to kind of just make the tube cross section the right width and the right patterning inside of it to make this thing actually work. The printing, they used a Markergear printer. They kind of adapted it to become a multi-material printer, and they used just regular PLA. And they also use, which is really nice actually, they use Fiberflex 40D TPU. It's like a TPU from Fiberology. It's a Polish company, and there's a Shore D40 hardness TPU. It's quite new compared to the other ones, like Philoflex, Ninja Tech, whatever, all those guys, Red Cross, whatever. Yeah, I like the fact that they use something like this. And also, flexible tubes are not something we really think about 3D printing a lot. We're very bad at making things watertight or airtight. We're typically very bad at making things flexible and last a long time. So I think it's a fantastic example of using a modified, heavily modified, probably desktop 3D printer to make a quite advanced device that is kind of like in an area we don't really think of. Tubes. Who cares, right? But tubes are really important for a lot of machinery. Also, tubes are important for soft robotics and stuff like that. So I think this is a really great example. So I use a Markergear M3ID for this. um, and the paper is called Compact Peristaltic Vacuum Pumps via Multi-Material Extrusion. And again, this has broader implications in vacuum pumps generally, in pumps, and different types of pumping applications, and different types of medical and industrial devices. So I think, and just this is broader, part of a much broader development of much more exciting developments to come, where we can really spread technology worldwide, spread science and healing worldwide through 3D printing. The researchers worked on this are Han Yu Lee, Jorge Cañada, and Luis Fernando Velasquez Garcia. Now, what's also good, by the way, is that this research was sponsored by the Empirico Corporation, which sounds like something out of sci-fi, but it isn't. It's a biotech company that is doing point-of-care diagnostics. So they really could be using this to really move this mass spectrometer more into the field, or use a peristaltic pump to, I don't know, I don't know about dialysis, low-cost 3D printed dialysis. I don't know if there's a market for that, but they could be using this for in a number of years for a real life application. So I really like that. Great stuff there by MIT. The next piece of news, I thought this was interesting because it was from Visitech. Now, Visitech is a company that you've probably used their stuff, definitely indirectly, but you're probably not familiar with them. And they put out a press release, and I thought this was nice. And I thought this was something that maybe a lot of people hadn't expected. Now, what's Visitech? Visitech is a Norwegian company, and it makes the optics, right, for a lot of 3D printing systems. They also make optics for industrial kind of equipment, laser etching equipment, other like kind of lithography and line type of equipment and stuff like this, and industrial kind of processes. They're very specialized firm. They're relatively small, and we always think of these optics companies, the laser companies, to be like Trumpf and stuff, to be very, very large, and the LED companies and all the kind of the optics DMD companies, stuff like that. We tend to think of really giant corporations that make these things. In this case, it's a relatively small company, relatively unknown, but they make a ton of different optics that work for powder bed fusion systems, so MSLA, for LED-based systems, vat polymerization, DLP, all these kind of things they make kind of like the optics for. Now, what they have released and told us about is that, well, they a while back bought a company in the US called Keynote Photonics. Right. And now they want to double their sales by 2025 because of explosive growth in 3D printing. So they're seeing explosive growth in 3D printing, explosive demand for their optic systems. And they've decided not to open a factory in China, not to open a factory, another one in Norway or something like that, which, by the way, it would be very expensive, but to open one in the US because they believe in growth in 3D printing in the US market. So this is a really, really great thing. I think, and they're betting down on U.S. manufacturing. They're betting that a lot of people are going to be requiring equipment for them in the U.S., and they're betting on a premium of this being made and supported in the United States of America. So that's, I think, great news. Another thing that is absolutely wonderful is that this is a relatively small company, and they're really determining the future of 3D printing through these light sources for a lot of processes. Um, there's another company called ScanLab, which also is really, really, really very crucial. And we don't really talk about these firms. They kind of like, they're kind of low key, and they do business directly with the large companies that are working in vat polymerization and powder bed fusion, and they do deal directly with them, and they all know who they are. So they don't really come out. And the idea is these guys are saying, look, we're going to build a big factory in the U.S., and the reason for that is explosive growth in the U.S. in 3D printing. As demand for optic systems, I think is a really great thing. Anyway, my name is Joris Peels. This was 3D Printing Unpeeled, brought to you by 3dprint.com. I hope you found this useful and helpful, and thank you very much for your time. Have a great day.